All right, ready to dive into something a little different today? Databases. I know, might not sound like the most thrilling adventure.
Yeah, you wouldn't think so, right?
But trust me on this one, this is a story and a legacy that's going to blow your mind.
What's really interesting here is we're not talking about your typical modern databases. This is going way back. Back to mainframes, punch cards, a system born during the space race.
Wait, are you serious? So while astronauts are shooting for the moon, someone down here is building a database. What's the connection?
Okay, so picture this. It's the 1960s. The Apollo program is in full swing, and they have a problem, a massive one. Millions of parts all need to be tracked, managed, assembled with absolute precision. And that's where IMS comes in.
IMS. What is that?
Information Management System, developed by IBM. IMS was their answer to the Apollo program's logistical nightmare. It was designed to handle complexity on a scale never seen before.
So this IMS thing was basically mission control for rocket parts. That's actually kind of cool.
It is. And get this, it's still going strong today. We're talking about a system that's been powering businesses for over half a century, handling billions, with a B, transactions every single day.
Hold on. You're telling me a database built in the 60s is still running things in today's world with all this lightning-fast tech? How?
It's really a testament to its robust architecture and its ability to adapt. But honestly, what's mind-blowing is that one of IMS's core innovations was revolutionary back then and is still a cornerstone of data management today, the separation of coding and data.
Okay, back in the 60s, how did they even handle data without separating it from the code?
It was messy, to say the least. Mainframe applications back then were this jumbled mix of code and data, making them super difficult to manage and update. And then IMS came along and changed all that, introducing something called DLI, Data Language Interface.
So DLI was like the great untangler, created order from chaos.
Yeah, it created this clear separation, letting applications access and manipulate data without being tied to the specific code. It's like a universal translator, letting programs written in different languages work with the database seamlessly.
That's brilliant. So instead of everyone speaking these different coding dialects, DLI created this common language for talking to the database.
Precisely. And this flexibility was key to IMS's success. Businesses everywhere started to see its potential.
Okay, I'm starting to see how this IMS thing became such a big deal, but you mentioned it has two main parts, the database manager and the transaction manager. What do those do?
Okay, so think of the database manager as the librarian. It handles the storage and retrieval of information, keeping everything organized and accessible. The transaction manager, on the other hand, is like the air traffic controller, managing that constant flow of incoming requests, making sure everything runs smoothly.
So one keeps things tidy and the other keeps things moving. But here's the million-dollar question. Why should we care about a database from the 60s? In today's world, with all this new tech, is it just nostalgia?
No, not nostalgia at all. IMS is still relevant because it delivers where it matters most. Performance, reliability, and scalability.
All right, I'm listening. Sell me on these strengths. Let's start with performance. How does a system designed before the internet was even a thing keep up with today's speed?
IMS was built for speed from day one. Remember, it had to handle the demands of the space program, where every millisecond counted. So even today, it excels at high-volume transactions with minimal lag, making it ideal for mission-critical applications, where delays are just not an option.
Okay, so it's fast. But what about reliability? Can you really trust a system older than most people using it? Isn't it kind of creaky, prone to crashes?
That's where IMS really shines. It was designed with data integrity as a top priority. Even if there's a system crash, which, by the way, is incredibly rare, IMS has built-in recovery options to ensure data consistency and accuracy. Think of it as a database obsessed with backups and redundancy.
So it's like a digital fortress, protecting your data with layers of security.
Exactly. And that's why industries like banking, telecommunications, even governments rely on it to handle their most sensitive information. They know they can trust IMS to keep things safe and sound.
All right, fast and reliable. I'm starting to get it. But what about scalability? Can it handle the ever-growing mountains of data that businesses are dealing with today?
Another area where IMS excels, it's designed to grow with your needs, handling increasing data loads without breaking a sweat. You can throw more data at it and it just keeps chugging along, processing everything efficiently.
So it's like a database with this insatiable appetite, always hungry for more.
Exactly. It can scale from a few gigabytes to terabytes of data without sacrificing performance. That's a level of scalability that many modern databases struggle to achieve.
Okay, so we've got speed, reliability, and scalability. All impressive qualities. But where would you actually find IMS in action today? Is it just a relic of the past, or the real-world applications?
You'd be surprised. IMS is still heavily used in industries like banking, telecommunications, retail, processing millions of transactions every second, managing customer information, and streamlining supply chains.
Wow, that's impressive. So the next time I'm using an ATM or buying something online, there's a chance IMS is working behind the scenes.
It's highly likely. It's the silent workhorse, powering critical systems all around the world, and it's doing it with a level of efficiency and reliability that few other databases can match.
Okay, I'm officially intrigued. But now I'm curious, how does IMS stack up against those shiny, modern relational databases everyone's talking about?
That's where things get really interesting. It's a bit like comparing a classic muscle car to a sleek, modern sports car. Both have their strengths and weaknesses.
All right, lay it on me. What are the key differences?
The core difference is how they store data. Relational databases store data in tables with relationships between them, like a giant interconnected spreadsheet. IMS uses a hierarchical model, which is more like a family tree, with data organized in a branching top-down structure.
Interesting. So it's like two different ways of organizing information. One, flat and interconnected. The other, hierarchical and branching.
Exactly. And each approach has its pros and cons.
Okay, let's talk pros and cons. Let's start with IMS and its family tree approach. What are the benefits of organizing data that way?
Well, for certain tasks, especially those involving highly structured data, the hierarchical model can be incredibly efficient. It's like having this perfectly organized filing cabinet. You know exactly where each piece of information is. You can retrieve data almost instantly, making it perfect for high-speed transactions, complex queries, where performance is really important.
So IMS is all about speed and efficiency, especially for specific tasks.
You got it. And that's one reason it's still so widely used in industries like banking and finance, where transactions need to be processed quickly and accurately.
That makes sense. But you mentioned disadvantages. What are the downsides of this hierarchical model?
Well, its strength can also be its weakness. That rigid structure, while great for efficiency, can make it tough to adapt to changing needs or handle those ad hoc queries that don't fit neatly into the predefined hierarchy.
So it's like a well-oiled machine, but if you throw a wrench in the works, it can be difficult to get things back on track.
That's a good way to put it. And that's where relational databases come in.
All right, let's talk about those sleek, modern sport cars of the database world. What are their strengths?
Relational databases are all about flexibility and adaptability. They can handle a wider variety of data types and structures, making them well-suited for applications where the data is constantly changing.
So they're more like generalists, able to handle a wider range of tasks.
Exactly. And they're also generally easier to integrate with modern apps and tools, which is a big plus in today's world.
Okay, so they're flexible and adaptable. But every rose has its thorns, right? What are the downsides of relational databases?
Well, that flexibility comes with a price tag. Relational databases can be less efficient than hierarchical databases, especially for tasks involving large volumes of highly structured data. They also require more complex queries to navigate the relationships between tables, and that can impact performance.
So it's a trade-off.
Yeah.
Flexibility versus efficiency.
You got it. And the best choice depends on the needs of the application. It's like choosing the right tool for the job. Sometimes you need a hammer, sometimes you need a screwdriver. There's no one-size-fits-all.
Okay, I'm starting to see the differences. But can we dive a bit deeper into how IMS's hierarchical model actually works? What does that family tree structure look like in practice?
Sure. Let's imagine a simple employee database. In IMS, the company itself would be at the top of the tree, the root segment, containing general info. Branching out from there, you'd have departments, each a dependent segment with its own data. Then, under each department, you'd have individual employees, again with their specific data, another level of dependent segments.
So it's a nested structure, with each level giving more specific info.
Exactly. And this built-in hierarchy is one reason why IMS can be so fast. For certain tasks, it's like having a roadmap. Tells you exactly where to find the info you need. You don't have to waste time searching or figuring out relationships. It's all laid out in a clear, logical way.
That makes sense. But you said earlier that setting up this hierarchical structure can be complex. Why is that?
Well, defining that hierarchy up front takes careful planning. It's like creating blueprints for a building. You need to think about how everything will fit together, because once it's built, it's not easy to make major changes.
So you're saying it's not as simple as just throwing data into the system.
Right. It requires a more structured approach. And that can be a challenge for some organizations, especially those used to the flexibility of relational databases.
Okay, I see the trade-offs. But let's go back to that speed advantage. You mentioned some pretty impressive stats earlier. Just how fast can IMS be?
Get this, IMS can run over 117,000 database updates per second.
Wow, that's insane. How does it achieve that kind of speed?
It all goes back to that hierarchical structure. Because the relationships are already there, the system doesn't have to waste time figuring out how different pieces of data are connected. It's like having a superhighway with dedicated lanes for each type of information. Everything flows smoothly and quickly.
Okay, so the structure is the secret sauce. But besides speed, are there any other benefits to using IMS?
Absolutely. In addition to speed, IMS is known for reliability, security, and scalability. It also offers efficient storage, using minimal disk space compared to other database systems. And cost-wise, it can be surprisingly cost-effective, especially when you consider how long it lasts and its proven track record.
All right, we've covered a lot, and I'm starting to see why IMS has been around for so long. But I'm guessing there's even more to explore. What other types of IMS databases are there? What are their specialties?
Well, you have the full-function databases, which are the workhorses, capable of handling a wide range of operations, like queries, updates, deletions, additions. They're like the Swiss Army knives of the IMS world, versatile and efficient. And then you have the fast path databases, all about speed, perfect for handling high-volume transactions.
Okay, so we've got the versatile workhorses and the speed demons. What else?
And then you have the HALDBs, high availability large databases, these are the heavyweights, capable of handling massive amounts of data, over 40 terabytes to be exact.
Whoa, that's a ton of data. What are those typically used for?
They're designed for mission-critical systems that require 24/7 uptime and can handle massive amounts of information without any issues. Think of them as the bedrock of large organizations, storing and managing the data that keeps everything running smoothly.
Okay, so we've got a whole family of IMS databases, each with its own strengths and specialties. But we've been talking a lot about the Database Manager. What about the other half? The IMS Transaction Manager. What's its role in all of this?
That's where we move from managing data to managing the actions taken on that data. The IMS Transaction Manager is like Grand Central Station. It's handling all the incoming and outgoing traffic, making sure everything is processed efficiently and securely.
So it's like the conductor of an orchestra, coordinating all the different instruments to create a symphony of data.
That's a great analogy. And just like a conductor needs to be aware of every section of the orchestra, the Transaction Manager needs to handle a variety of tasks. Processing transactions, managing system commands, ensuring smooth communication between different parts of the IMS environment.
So it's a multi-talented maestro, keeping everything in sync.
Precisely. And it's crucial for the smooth and efficient operation of IMS systems, especially in large, complex environments. It's a marvel of engineering when you consider how it's evolved over time. But despite all the updates, IMS still has this connection to its past, particularly in its programming language.
You're talking about DLI, right? The one we mentioned before. It's like the native language of IMS, but does anyone actually still use it?
DLI is still very much in use. It's the most direct way to talk to those IMS databases, perfectly suited for that hierarchical structure. Though I guess it might seem a bit old-fashioned compared to languages like Python or Java, it's incredibly efficient for certain tasks.
Okay, I'm picturing a group of like tech-savvy monks huddled over these ancient scrolls, whispering in DLI. What's it actually like to use?
It's all about commands and syntax. You use specific instructions to tell the database what to do, like retrieve a record or add new data. For example, if you wanted to find an employee's record, you'd use a command like GU. That stands for get unique. Then you'd specify the search criteria, like an employee ID, and DLI would fetch that info from the database.
So it's like a super specialized search tool. But instead of keywords, you're using these cryptic commands.
Exactly. And there's a whole set of commands for different actions. Inserting new records, deleting records, updating existing information. DLI can handle it all.
Sounds powerful, but also maybe a little intimidating. Is knowing DLI like a requirement for working with IMS?
Not necessarily. One of the cool things about IMS is that it's learned to speak other languages over time. It can now interact with modern programming languages like, COBOL and Java.
So it's like IMS has built these bridges to the modern world of coding, allowing developers to work with it without having to decipher those ancient scrolls.
Exactly. There are special libraries, APIs, that act as translators, allowing those languages to send requests and receive data from those IMS databases.
That's a relief. I was worried I'd have to dust off my Latin textbook to understand this thing. But seriously, That adaptability is impressive for a system that's been around for so long.
It's crucial for IMS to stay relevant, you know? Embracing these modern programming languages means that a new generation of developers can maintain and enhance this powerful system, keeping it relevant for years to come.
Okay, so we've got this powerful system, long history, unique way of organizing data, its own language, and it can talk to other systems, programming languages. It's like a tech time traveler, evolving through the decades.
It really is. And it's a great example of how a solid foundation and continuous innovation can keep a system going strong, even in a world where tech is always changing.
So as we wrap up this deep dive into IMS, what's the takeaway for our listeners? Why should they care about this system that most people have probably never even heard of?
I think IMS shows us that we shouldn't dismiss those older technologies just because they've been around a while. Sometimes the systems that have stood the test of time have really valuable lessons to teach us about design, reliability, and adaptability.
That's a great point.
Yes.
It's so easy to get caught up in the hype of what's new, but IMS reminds us that sometimes the old ways still have a lot to offer.
Absolutely. It also highlights the importance of understanding the strengths and weaknesses of different approaches. There's no one-size-fits-all solution in the world of data management. The key is choosing the right tool for the job and not being afraid to combine those legacy systems with newer technologies.
So IMS might be a veteran, but it's still got game.
Oh, without a doubt. It's proof of the power of innovation and adaptability. And it's a reminder that we can learn a lot from the history of technology. Insights that can help us build a better future.
Okay, we've gone from rocket parts to global banking, uncovering this whole hidden world of IMS. But before we go, I have one more question.
Yeah.
What does the future hold for this enduring system? Is it destined to be a museum piece? Or can it find a place in the age of cloud computing, big data, and AI?
That's the exciting part. Despite its age, IMS shows no signs of slowing down. IBM is actively investing in its future, integrating it with cloud platforms, big data analytics tools, and even exploring AI.
Wait, really? They're teaching an old dog new tricks.
Yep. And it's working. IMS is being reimagined for today's world, finding new uses in things like real-time analytics, fraud detection, even personalized medicine.
So it's like IMS is getting a second wind, proving that sometimes those tried and true solutions are the best.
Exactly. It's amazing proof of the value of well-designed systems and the people who continue to push the boundaries of what's possible.
This is all fascinating stuff. But before we get too caught up in the future, let's address something that often comes up with these older technologies, the skills gap.
Ah, yes, that's a valid concern. As systems age, the pool of experts shrinks. It's like finding mechanics who can still fix a vintage car.
Right. So how do we make sure these systems continue to be supported and maintained as that original generation of experts retires? Are we looking at a digital brain drain?
That's a real risk, but there are some initiatives to try and address it.
Okay, that's good. Tell me more about these initiatives.
Yeah.
What are they doing to bridge this skills gap and pass the torch to a new generation of IMS experts?
Well, IBM offers training and certification programs specifically for IMS, helping new IT professionals learn what they need. And there are online communities and forums where IMS experts share their knowledge and mentor others.
So it's like a digital apprenticeship where these aspiring IMS gurus can learn from the masters.
Exactly. And some organizations are doing mentorship programs, pairing up those experienced IMS pros with newer IT staff to pass on that knowledge and make sure there's a smooth transition.
That's good to hear. It sounds like there's a real push to keep that IMS knowledge alive. But let's be honest, in a world that's always chasing the newest, shiniest tech, is it realistic to expect this new generation to embrace something older than they are?
That's a fair question, and it's a challenge. The industry has to show them the unique advantages of IMS, the career opportunities, the satisfaction of mastering a system like this. So powerful and long-lasting.
So it's about showing them the cool factor, that IMS is more than just a relic of the past, it's got a future.
Exactly. And that's what we need to do to attract new talent to the world of IMS. Show them that working with this tech is not just about keeping old systems running, it's about pushing the boundaries of what's possible with data management.
Okay, you've convinced me. IMS has a story and it needs to be heard. But we've covered so much. My brain's feeling a bit like an overloaded circuit right now.
I know what you mean. It is a lot to take in, but it's fascinating, isn't it?
Totally. We've gone from rocket parts to global banking, from the details of these hierarchical data structures to the whole challenge of the skills gap. It's been a whirlwind tour through IMS, and I'm honestly amazed at how much there is to learn.
Me too. And we've only scratched the surface. There's so much more to explore, so many interesting details and stories that we didn't even have time for. But I think we've got a good foundation now for understanding the system.
You're right, we've just laid the groundwork.
Yeah,
But that's sometimes the best part, realizing how much more there is out there.
I agree. And, who knows? Maybe someday we'll revisit IMS and go even deeper. But for now, I think we need to just let everything sink in a bit.
I think you're right.
Yeah.
This deep dive has been a real eye-opener, and I have to say, I'm going to be looking at databases in a whole new way from now on.
Well, I'm glad to hear it, because IMS really is a remarkable system, and it deserves all the attention it can get.
I couldn't agree more. It's a testament to the power of innovation, the importance of adaptability, and the enduring legacy of a well-designed system.
Well said. And on that note, I think it's time to wrap things up.
You're right. It's been a fantastic journey exploring the world of IMS. But like all good things, it must come to an end. For now, at least. But who knows? Maybe we'll revisit this fascinating world sometime in the future.
I love that.
And to our listeners, thank you for joining us on this deep dive into IMS. We hope you've enjoyed it as much as we have. Until next time, keep exploring, keep learning, and never underestimate the power of a good database, no matter how old it might be.